Padilla. This is the comparative study and aerodynamic analysis of various wing shapes for incompressible flow. It's the final project for EAS 3101 with Dr. Ozbay. I'm going to be doing part A. My partner Garen Lamb is going to be doing part B. So for part A, we're going to start with wing 2A, which is the rectangular wing with the aspect ratio of 10. And we're going to go into XFLR5 to create the geometry. So to do that, we'll click on Module and Direct Foil Design. From here, you can click on Foil and then NACA foils, and we're using 2415, which is already saved in here. I'll click OK, and there's our NACA 2415 foil. From here, go into Module, X-Foil Direct Analysis. We're going to define an analysis with a free stream velocity of 50 meters per second. Our Reynolds number comes out to 3,333,333. That's just using the density and the viscosity that we're given, as well as the free stream velocity. So we'll click OK. We want our angle of attack to start at -5 and then move in increments of 1 degree to 15 degrees. And then from here, we'll also define a batch analysis from 250,000 to 5 million, as it includes the 3 million or so Reynolds number. Let's have the same range for alpha, and we'll analyze here. Now we're gonna create our wings, or our wings, sorry. So go into wing and plane design, click on plane, define a new plane. We don't need a fin nor elevator, just the wing, so we'll define the wing here. Aspect ratio is 10, so this y would be 5 meters, 0 to 5. Chord length is 1 across the wing, as it's rectangular, and you can see here our aspect ratio is 10. Define the NACA 2415, and there's our wing. Save it, name it aspect ratio 10 rectangular. Save. Now here we're gonna define an analysis. Our V infinity is 50 meters per second. I'm gonna make sure this is LLT. You can go ahead and save. Then we'll press analyze. In our project report, the second part asks to plot the CL versus angle of attack, CLCD versus angle of attack, and CD versus angle of attack. So back into XFLR5, we'll go to module, back to Explore Direct Analysis. Click on this 3 million Reynolds number. That's the only one selected. We have our CL versus alpha right here. I'm going to right click here and then define the graph settings, change this to CLCD versus alpha. Here's our CLCD versus alpha graph. And then I'll change this one to our CD versus alpha. And there's our CD versus alpha graph. Now lastly, the project description wants us to, at 5 degrees angle of attack, plot the variation of local lift coefficient, induced angle of attack, and induced drag coefficient along the span of the wing. So to do that, we'll go back into XFLR 5, back into wing and plane design. So now that we created the analysis, we have our different angles of attack here. So we're gonna select 5. Actually, we're gonna go into here. We're gonna deselect all of these, only select 5. Click on this graph, current graph, reset graph skills. Now go back and define the graph settings. So the first one they want is the variation of local lift coefficient. So we'll click local lift coefficient and have the Y span. We have our 5 degree angle of attack selected already. And there's the graph of the variation of local lift coefficient along the span of the wing at 5 degree angle of attack. Now the variation of induced angle of attack. So we'll do the same thing, go into current graph, define graph settings, induced angle, Y span. And there's the graph of the variation of induced angle of attack along the wingspan. And then lastly, we're asked for the induced drag coefficient, Y span. And there's the variation of induced drag coefficient along the span of the wing at an angle of attack of 5. That concludes the video portion of part A. Again, Garen Lamb will be doing video portion of part B. And that's the final project. Thank you.